Okay, let's get started from where we stopped last class. This is the HSE recommendation, Health and Safety Executive, British authority. So according to their suggestion, the boundary between unacceptable and allowed region is 10 to minus 3 per person. That means the crew, one of the crew can be killed once in 1,000 years due to the accident occurred in the ship. This is, I think this is the study done by DMV, the Norwegian Classification Society. According to their study, the current risk levels, individual risk levels, varies with the ship type: oil tanker, chemical tanker, gas tanker, bulk carrier, blah blah blah. But all the risk with the ships below the intolerable risk, 10 to minus 3. So this is their Norwegian suggestion. What I mean is that the new ship should have risk level about 10 to minus 4 for crew and 10 times smaller than this value. What I mean is 10 to minus 5 for the public, the passengers of the ship. Societal risk. So this is the FN curve for all the ship types, and this is the kind of guidelines how to draw this line. So you can easily understand the boundaries. Anyway, this value is not important because the risk of the order of 10 to minus 3 is very low. The negligible. So this boundary is not important. The important boundary is this one, 10 to minus 3, between unacceptable risk region and allowed region. So 10 to minus 3 are considered the suggested the guidelines for the new ships. Value of preventing a fatality. What I mean is that we can improve the design, but design improvement needs money. So reasonable thinking is to compare the investment and the risk reduced by the investment. So for the decision, we needed to estimate the value of life. What is value of my life? What is the value of your life? We need to answer this question to make a decision. For example, if we change the ship design by investing $10 million, and we can save one life per month, then it is reasonable, $10 million to save one person per year. So to make a decision on the design change, we needed to estimate the value of life. So this is the value of life. Australia, Austria, Belgium, Canada, blah, blah, blah. So they estimated 3 different values. all values about life, the value of life, but the viewpoint are different. If you read carefully, the blue left columns would be definable by purely economic consideration, production value of man, or of course woman. What I mean is this value, the blue one, means the production made by the person who can be killed. What I mean is that the production of mine, if I can be killed for the accident. So what is the production of mine? It can be the salary times. For example, my salary is about $100,000 per year. Times I can work about 20 years in Christ if I granted tenure. So we can estimate the production of the professor Daejun-jan. This is about estimate done by but this only based on purely economic consideration. Another thing is about the second one is middle one. The middle one columns represent the societal value derived from the society indicators. There can be other indicators on any and the third one in yellow one columns represent the limit where no regulation should be implemented at individuals who do the resources better on life saving. That means how much I am willing to pay to save my life, neglecting all the regulations. There are many regulations on safety, but if we disregard all the regulations, how much I or the societies are willing to pay to save one person? Can you answer the question? The value of life? I recommend you this book. The title is The Price of Everything. This book is very, very interesting. It's worth reading. The author is Edward Rudolph Porter. This book consists of 9 chapters. First chapter, the price of things. Second, the price of life. Price of happiness. Price of women. Price of women. Price of work. Price of free things. I mean the price of culture. Price of faith. The price of religion. Okay. Price of future. This book is very interesting. The second chapter, the price of life, is concerning our current question. So I want to read you a part of the book. And that it is Korean, but in English it means the Australian government invested much money to prevent a terrorist attack. After simple calculation, he can estimate that the value of life, in this case, to investment to prevent the fatality caused by terrorism, is about $100 million. Far greater than any of them. So the price of price of life or value of life can be different from country to country, from viewpoint to viewpoint. Anyway, there's no universally accepted value of life, but shipping is international business. So we need a kind of a common basis to make a decision. Ship can be made in Korea or in China, in Japan or in Brazil, but the ship can go anywhere in the world. So the same safety standard should be applied to all the international shipping carriers. So FSA, Formal Safety Assessment Guideline, it is prepared by IMO. The FSA guideline submitted by Norway indicate that how about 3 million per person. So our value of life is 3 million according to Norwegian standard. Are you happy with that value? 3 million. If you have 3 million, in Korean 30억, we are very rich. So I hope some of you are very happy. But as I told you, there is kind of span between the countries. So maybe the value of life can be extended to 1.5 to $6 million per person. So this is kind of cost-effective approach. I'm sorry for the language, but the overall philosophy is that we needed to compare the investment for design change and the number of life can be saved. So if we define the value of life, the calculation is very simple. So we overviewed the safety door argument, but offshore practice is different. In offshore practice in UK regulations, we needed to apply Allah principle, and there are regulations on TR, temporary refuge impairment frequency. So the safety critical systems should have the impairment frequency less than 10 to minus 4 per year. This is the regulation imposed on concerning the safety. What it means that the UK regulation never mentioned the value of life. They just imposed the regulation on the impairment frequency. Okay, because if this frequency is low, we can save a lot of life, because most fatality, do you remember? Most fatality have been observed during the ER, escape, evacuation, and rescue. So these are structural support, life support, command support, and evacuation. And this, if we have a big accident, all the safety system can be damaged ultimately. So this impairment should be guaranteed for limited time. So usually 30 minutes to 40 minutes. After 30 minutes, we don't care, even though it is impaired, because there is big fire, and if the structure can withstand the fire for 30 minutes, then the crew can escape from the from the installation. If we require that the structure should be sound, should be remained with its structural integrity for 1 hour, that means we can make the structure stronger. But that kind of approach means that we need to invest more money in the structural design. So impairment has a meaning only for limited time. So usually 30 minutes. Can you understand me? We have accident and there are many safety critical systems. If the safety critical systems can survive for 30 minutes, it's okay. After 30 minutes, after crew can escape from the installation, we don't care about the integrity of the safety system.
The number of times is the most, the failure most, and least.
You mean this value?
30 minutes.
30 minutes. 30 minutes. 30 minutes should be decided in principle during the feed design. I mean the minimum required time for escape can depend on the complexity of the installation or the size of the installation. So during the feed front-end engineering design, we needed to estimate the real time required for escape. So this is just example, okay? So the operator, the designer should estimate the time, and they should make a decision. IR, individual risk, not infrared. IR, individual risk. UK regulation do not mention directly the requirement about individual risk. So that's why. Do you know why? The IMO directly want to estimate the value of life, but in offshore industry, it is kind of taboo to estimate the value of life. So they never, the HAC or the Norwegian regulation or the oil companies, ExxonMobil, BP, Shell, they never mention, they never pinpoint the value of life. Okay, even though it is more practical, it would be more practical to define, to set the value for the value of life, but they never mention, they never single out the value of life. So they are taking indirect approach to regulation, to imposing regulation on safety. This is Norwegian regulations. They give only qualitative guideline, not numeric regulations. So interesting point is that UK imposed some numeric value here, but in Norway there is no numeric regulation. Norwegian authority requires that the operator should develop their own guidelines. For example, Statoil is a Norwegian operator, oil major. Operator means oil major. You understand? Operator is not the worker who are operating the installation. In offshore industry, operator means the oil companies. Okay? Statoil is a Norwegian operator. Their standard is fatal accident rate is 10, and some others individual risk 10 to minus 3. Each company, each operator has their own guideline. government never imposed any specific value. Okay? So fatal accident rate 10 is about 4 times 10 to minus 4. Okay, you know now that the fatal accident rate can be related to average individual risk if we know the shift time. Okay, that is the half the year. Okay. Any questions? The next topic is lessons from major accident. The offshore regulations has been changed if we had a big accident. So regulation, from some viewpoint, regulation are product of a big accident. So let's take a look at some big accident. There are two. Let's compare two accidents. One is Piper Alpha 8, July 6th, 1988. Brent A, July 5, 1988. So two accidents occurred nearly at the same time. And the leak source, blind flange, gasket inner flange, ignition source, ignition by unknown source, probably by deluge. What is deluge? Deluge is the kind of showering. What is in Korean? Big sprinkler. Okay, we have if we have fire detection, we spray a lot of, literally pour a lot of seawater on equipment to prevent the heating up of the equipment. So some of you are Christian. What is deluge in Bible? I'm a Christian. Or Catholic. Aren't you Catholic? You're Catholic. So deluge is Noah's. Yeah, it's Noah made a big ship. What is the name of the big ship? Noah's Yeah, in English I mean Ark, Noah's Ark. And because there was a big rain and flooding, so deluge is flooding. So we pour a lot of seawater on equipment. That is one of the safety equipment, deluge. And there was explosion, overpressure about 0.3, the same magnitude of explosion. Deluge not initiated, I will show why. Started on gas detection, subsequent fire escalated immediately to other areas. Only few minutes fire. There was a fire, but the lifetime of the fire was short for Brent A platform. Consequence is 167 fatalities. That means 167 people are killed in this accident, and only 2 injuries, small injuries for Brent A accident. 2 accidents occurred nearly the same time. That means the safety regulation for the 2 platforms were not that different, and the accident type and were similar, but the consequence was quite different. So let's see what happened to Pipe A. Pipe Alpha platform, Pipe A, Pipe Alpha platform accident, where Pipe Alpha platform is the name of the platform, the time, how gas leak was escalated to an extensive catastrophe. There was a gas leak. We will see what happened in detail. Major safety system failed. Major safety system was not activated for some reasons, and 166 people are killed, plus 1 in hospital. So you remember the classification of fatality: immediate fatality and delayed fatality. So immediate fatality plus 1 delayed fatality. Impact there, because this accident was really mind-boggling. There was official survey. The survey was led by Lord Cullen, and the survey team published a report. The name of the report is Cullen Report. It is very important report. And after this report, safety case and QRA became normal practice in the offshore industry. Recalling the history of safety design in offshore, Norwegians tried to implement QRA from early 1970s, but UK had been neglecting those kind of approach, quantitative risk assessment. But after this accident, UK authorities accepted the approach done by Norwegians. And because Norway and the UK are the two major countries in offshore industry, safety study and QRA became the kind of world standard in offshore industry. It's the photograph of the accident at the time. I think this time, the time is around the Seoul Olympic in Korea. So Koreans were busy then watching the games, but there was a big accident in the other part of the world, another part of the world. So let's see what happened there. A gas leak from a blind flange in the compression area. What does it mean? That the compressor was out of service and it was repaired. So after maintenance, the crew repeatedly tried to start the compressor. They tried to activate the compressor, but they did not know the downstream piping had been isolated and blocked. So compressors and pumpers, the turbo machineries have kind of safety function. If the downstream pressure is too high, it should be turned off. So the crew tried to activate the compressor, but the compressor had internal logic. So the compressor was initially started, but downstream pressure was increased. So the compressor has internal safety logic to turn itself down. So operator didn't know. So they are very hardworking and persistent. So they try again. So there was a leak somewhere downstream the compressor, and the gas leak ignited within a few seconds. So it gives us an explosion 0.3 to 0.4. So it was not that serious explosion. It is a kind of small explosion, but this explosion, blast means explosion. This blast damaged some equipment and piping. So unfortunately there was oil leak, and then we have oil fire. So if the oil fire had been extinguished, that could have been the end of the story, but it was not. Firewater was not operated. So firewater, what is the source of the firewater? SC water. There should be seawater. There should be seawater pump. Seawater pumps should be pumping up the seawater, but the firewater pump were deactivated because for divers. There are some underwater working. Divers was down there. So if the firewater pump is working, the firewater pump will suck seawater. So the divers can be sucked into the seawater pump. So they are afraid of that situation. So the firewood were deactivated. So there was a fire, but there was no firewood coming. So the fire was escalated to gas riser. What is riser? The pipeline from seabed. The riser was damaged, so a lot of well fluid got out of the riser. Tons per second. Okay, tons per second here. So the fire grew catastrophically. What a pronunciation. But the crew escaped the accommodation. They survived, most of them survived the first explosion and the fire. There was an explosion and the big fire, but most of them still survived. So they gathered in the accommodation room, kind of temporary refugee, but they were given no further instruction what to do. So they just wait there. Telecommunication system was down. They expected helicopter evacuation. Helicopter is a very convenient machine. As you can see in many movies. But think about helicopter operation in this case. Helicopter approach is really impossible when you have a fire in offshore installation. So in a daily life, they commuted by helicopter. So they expected they can escape by helicopter. But in fire case, helicopter is useless. So they wait there and are killed. So 167 died at the scene, one later in hospital. I think it should be 166. Cause of death is not fire or explosion. In most cases, in building fire, as you well know, the main cause is smoke inhalation, the lack of oxygen. most of them were still in the room. It collapsed 1 hour later. So this is, if we assume that this is the room, we operator, we stayed there for 1 hour. They have a lot of time to escape, but they were given no instruction. 6-3 survived by jumping into the sea. So this is a very important lesson. Okay? This may be 20 meter high, so it needs a kind of courage. If I jump off here, maybe I can be killed or not. But if you stay there, you are absolutely killed. Can you understand me? So sometimes you needed to take a risk. So 6-3, take a risk to jump into the sea. 2 crew died in attempt to save the others. So I think this number is right. I'm not quite sure. Anyway, the fatality is around 170. So there can be some questions about the safety. First question is, was there any guideline or checklist which the crew should follow before they did the startup? The crew were hardworking. They did their job, tried to start up the compressor, but they are not that smart. But it is the fault of the operators. So there should be kind of safety system. Safety system is more than the hardware or software. Safety system is kind of should be part of management or normal daily life, daily working. So there should be permit to work system. If you start up the compressor, you should check this. So this kind of list or a system is called the permit to work system. In shipyard, there can be some fatality during painting. Ships are very big, so some workers are killed for lack of oxygen. They paint inside the tank, but as the thinner vaporized, they can be killed because of lack of oxygen. So there should be some kind of active ventilation system. Air should be blown into the closed system when there is a painting job. So those kind of checklist is called the permit to work. The gas leak. So the question is, where are the ignition sources that might be caused the ignition? So the question is, what are the ignition sources for this accident? So even human activities can cause ignition. What I mean is that if we have a gas here, if I swing like this, I can generate 20 ignition sources by just doing like this. So preventing ignition source completely are nearly impossible. Okay, the ignition energy is very low. So it is really impossible to remove all the ignition source. So we need to remove the inventory or gas. That kind of action can be reasonable, but remove all the ignition sources. It's not a reasonable source. Anyway, all the electric equipment in offshore industry should be explosion-proof type. Another question is, was it possible to operate the process with the fire water system shut down? So in these days, normal practice was if there is no fire water, no operation. But on those days, there was no those kind of safety requirement. So even though there was no fire water, they tried to operate the plant. So this is also kind of permit to work system. No fire water, no operation. No fire and gas detection system, no operation. The riser damaged. So how could the fuel leak be that much? I mentioned tons per second. So was that possible? That amount is possible? So you should know the flow rate, the velocity of leak. The velocity of leak is nearly sonic. Theoretically, it is sonic. What I mean is that here pressure is 1 bar. Pressure here maybe 1.5 bar. The flow rate is proportional to square root of pressure difference. But if the pressure is greater than 2 bar, for example 100 bar, the riser pressure can be 100 bar. In this case, the flow rate is just proportional to 100 bar. And the leak here is the sonic velocity of this at this pressure. So at 1 bar, the sonic velocity is 340 meters per second at 1 bar. How about at 100 bar? Maybe 1000 meters per second or greater. So what I mean is that this amount of leak, turns per second, is feasible if the riser is ruptured. How long was the fuel jet? How long? How long does it take to start the jet? As you can see, the accident in Gulf of Mexico last year, if there was no stop valve on the wellhead, the leak continues as the well pressure is down. So it's very dangerous. So we need kind of some safety system to block the well fluid when we have some accident on the surface installations. The crew escaped the accommodation, but they are until they are killed by smoke. So was there no one to command in emergency? In emergency, there should be someone who tells what to do. After the accident, there should be a kind of installation manager. So installation manager should make a decision. Like, let's jump into the sea. How was the communication system damaged by the explosion? So communication system now is classified as safety critical system. Weren't they informed of the difficulty of helicopter evacuation? They believe that they can escape by helicopter, but they should be informed that helicopter evacuation is impossible in case of fire. Another question is, how could the smoke sneak into the room? So the current standard is that the smoke cannot ingress into the temporary refuge. So there are some regulations on temporary refuge, TL. One is strength against fire. Second, strength against explosion. Third, strength tightness against smoke. And there are other things. Anyway, the temporary refuge should stand, survive explosion, fire, and smoke. Another funny thing, silly thing about the Pipe Alpha platform was the layout of the installation. An offshore installation consists of several modules. One is accommodation, utility process, well fluid separation, well module including risers. Can you understand each of them? Accommodation, yep, I have a figure here. This is accommodation area. Operators usually are there. There are some risers from wells, and these well fluid are separated in the well fluid separation unit. So the well fluid are separated into crude, gas, and produced water. And gas and crude are treated in process area. This process area needs a lot of utility, heating medium, cooling medium, electricity. So utility area generate those required utility for the process area, and people live there. Because utility systems are well defined, like generators, gas turbines. So we know very well about this. So they are relatively safe. Relatively safe means that they are dangerous, but they are more safe than the process area. So typical layout is living area, utility area, process area, and well fluid separation unit, the risers, and the flare systems. This is the typical layout of of the current offshore installations. But this is the layout of the Pipe Alpha platform. Utility here, central control room here, accommodation here, gas compression here, separation here, well module here. If there is a fire here, gas compression module, the fire can damage. Fire is easy to escalate to upward direction. So the fire here can easily damage the accommodation unit. So this is the current new layout. There's accommodation here, central control room. All the electronic equipment here, emergency system here, utility, gas compression, blah blah blah. So these process areas are separated by accommodation areas by emergency system and utility. And these days there are walls here, two walls. One is fire, the other wall is blast walls. So the accommodation areas are protected by two walls and some buffer modules. But this is just concept. Real offshore plant looks like this. This is FPSO owned by Total, Akpo FPSO. So real module is a little different from this kind of a simple layout. So permitted to work system was suggested. As I told you, it is very difficult to remove all the ignition sources, and the fire water system, there is kind of permit to work concerning the fire water system. So if fire water is not available, operation should be stopped. So no fire water, no operation. And riser should be thermally insulated against the jet fire. If the there is a possibility that the riser can be damaged by some jet fire, the riser should be insulated. This is the current regulation. But the mitigating safety system kind of limited period of time basis. I mean that they don't have to preserve their strength for a long time. They don't have to. 30 minutes or 40 minutes is enough. And the field study should estimate the escape time. And helicopters should not be used for escaping means in case of fire. Okay, that's all I prepared for today. Any questions?